video, you will learn on how to compute the continuity of a function at a point. Example 1. Determine whether the function fx is continuous at x equals to -4, -1, and 2. To know whether the function is continuous at x equals to -4 or not, you have to check the three conditions of continuity, which the first condition is find f -4. So when x is -4, the function is 3. Second condition, check the left hand limit and right hand limit for -4. If you refer to the graph, as x approaches to -4 from left, the fx is approaches to 4. And then as x approaches to -4 from right, the fx is also approaches to 4. And then since left hand limit equals to the right hand limit, that means the limit of x approaches to -4 is exists and equals to 4. Then check the third condition, whether the first condition equals to the second condition or not. First condition, we have f -4. Second condition, we have limit of x approaches to -4. For the first condition, the value is 3. Second condition, we have the value 4. So they are not equal. Since the third condition is not satisfied, that means fx is not continuous at x equals to -4. Next question, determine whether the function is continuous at x equals to -1. To know whether it is continuous or not, we have to check the three conditions of continuity. The first one is find f -1. So when x is -1, the function is 3. Second condition, check the left hand limit and the right hand limit. For the left hand limit, refer to the graph. As x approaches to -1 from left, the function is 3. And then as x approaches -1 from right, the fx approaches to 3 also. That means since left hand limit equals to right hand limit, limit of x approaches to -1, fx is exists, which is 3. Third condition, check whether the first condition and the second condition is equal or not. First condition, we have 3. Second condition, we have also the value 3, so they are equal. That means the function is continuous at x equals to -1. Third question, determine whether the function is continuous at x equals to 2. Again, we have to check the conditions of continuity. First condition, find f2. So when x is 2, if you look at the graph here, there's no function here. So that means f2 is undefined. Since the first condition is not satisfied, we can make the conclusion that fx is not continuous at x equals to 2. Example 2. Sketch the graph of fx equals to 3 if x equals to 4, x plus 2 if x not equals to 4. And then determine whether fx is continuous at x equals to 4. First part of the question, we have to sketch the graph. First function we have is 3 when x equals to 4. This is a constant function, so we may draw the graph first. Draw x-axis, y-axis, then 0 in the middle. So when x is 4, the fx is 3. It should be a dot. Second function is x plus 2 when x not equals to 4. To draw this graph, you have to find the value when x is 4. What is the value of the fx? Substitute 4 into the function, you will get 4 plus 2, 6. And then find the value when x is 0. What is the value of the function? 0, substitute into the function. 0 plus 2 is 2. And then find when fx is 0, what is the value of x? It would be negative 2. Then we can sketch the graph. When x is 4, fx is 6. Not equal, so we should draw an empty circle here. When x is 0, fx is 2. And then when x is negative 2, fx is 0. Then draw a line, connecting the points, and label the graph. Next, to determine whether the function is continuous at x equals to 4 or not, we have to check the 3 conditions of continuity. The first one is find f4. So when x is 4, the function is 3. Second condition, we have to find left hand limit and right hand limit. If you refer to the graph from left, as x approaches to 4, the fx is 6. And then for right hand limit, as x approaches to 4 from right, the fx is also 6. Since left hand limit equals to right hand limit, that means limits of x approaches to 4 is exists and equals to 6. Finally, check the third condition. Check whether the first condition equal to the second condition or not. The value of the first condition is 3. For the second condition is 6. They are not equal, so that means fx is not continuous at x equals to 4. Example 3. Let fx equals to x squared plus 1 when x less than 2 and x plus 3 as x greater or equals to 2. Prove that f is continuous at x equals to 2. If you look at the function, we have two different functions here, so it's better to draw a number line so you can see the function clearly. As x less than 2, the function is x squared plus 1. For x equal or greater than 2, the function is x plus 3. Then to know whether the function is continuous at 2 or not, we have to check the 3 conditions of continuity. The first one is find f2. So when x is 2, the function that we have to use is x plus 3. Substitute 2 into the function, you will get 5. Second condition, check the left hand limit and the right hand limit. For left hand limit, we have to use the function x squared plus 1. For the right hand limit, we have to use the function x plus 3. And then just substitute the value of x into the function. You will get 2 square plus 1 equals to 5. Another one will be 2 plus 3 also equals to 5. Since left hand limit equals to right hand limit, that means limit of x approaches to 2 of the function is exists and equals to 5. Lastly, check whether the first condition equals to the second condition or not. Our value for the first condition is 5, second condition also 5. They are equal. That means the function is continuous at x equals to 2. Proven. Example 4. Determine the value of c if function fx is x squared minus 1 as x less or equals to 3 and 2cx as x greater than 3 is continuous at x equals to 3. It's better if we draw the number line first to label the function. For x equal or less than 3, the function is x squared minus 1. X greater than 3, the function is 2cx. And then to find the value of c, we know that the function is continuous at x equals to 3. So since it is continuous, we can apply the condition of continuity, which is the second condition. Second condition states that left hand limit is equals to the right hand limit. So for left hand limit, we have to use the function x squared minus 1. For right hand limit, we have to use the function 2cx, and then just substitute the value of x into the function. You will get 3 squared minus 1 equals to 2c times 3. On the left hand side we get 8, on the right side we get 6c. So that means c is 4 over 3. Example 5. Determine the constants c and d such that hx is continuous on the entire real line. If you look here, there are 3 different functions of hx, so it's better to draw the number line and label the function first. We have x, 4 and 9. For x less or equals to 4, the function is 2x. X greater than 4 less equals to 9, the function is c sub x plus d. X greater than 9, the function is x plus 1. We know that the function is continuous on the entire real line, so we can apply the second condition of continuity, which left hand limit equals to right hand limit. First, we compare the left hand limit and right hand limit for 4. Left hand limit for 4, we should use the function 2x. Right hand limit, we should use the function c sub x plus d, and then just substitute the value of x into the function. You will get 2 times 4 equals to c sub 4 plus d. Then simplify the equation, you will get d equals to 8 minus 2c, and let it be equation 1. Let's compare the left hand limit and right hand limit for 9. For the left hand limit, we have to use the function c sub x plus d. For right hand limit, we have to use the function x plus 1, and then just substitute the value of x into the function. You will get c sub 9 plus d equals to 9 plus 1, which is 3c plus d equals to 10. Let it be second equation. To get the values of c and d, we have to do simultaneous equation. First, we substitute the first equation into the second equation. 3c plus d, where our d is 8 minus 2c equals to 10. Then simplify this equation, you will get c equals to 2. To get value of d, we substitute the value of c into the first equation. D equals to 8 minus 2. C is 2, so 8 minus 4 is 4.